half adder we are having two inputs, okay, and we are getting the two outputs, that is sum and carry. Okay, when we are getting the carry and when we are getting the sum, see, anyway if you add two numbers means 0 plus 0 means sum is the output, right? Suppose this is my half adder, x and y are the input, and then s and c are the outputs. S means sum, c means carry. Why I am getting the carry here? Suppose 7 plus 6 I am adding here, then 7 plus 6 means 13. So 3 is my sum and 1 is my carry. Okay, so then 1 is getting here, that means 3 is the sum and carry is the 1. That means 3 is the units place and 1 is the tens place. Okay, so in that way we will add two numbers in our combinational circuits. This half adder trying to add the two inputs here. Okay, 0 plus 0, there is no sum and there is no carry. Okay, so if you add the 0 plus 0 means 0 only we are getting, right? So 0 and 0 only, and then 0 plus 1 means, okay, just give me 2 minutes. Yeah, uh, ஆமா. చెప్పరా. Sorry Priya. uh,
No,
Thank you.
no problems.
mm, huh. Okay, so this half adder, we are adding two numbers like this. Okay, 0 plus 0 I am giving. Okay, so sum output is 0. Okay, because 0 plus 0 you are adding, then 0 only I am getting. Then this is my sum, and there is no carry, right? So carry is also 0. And then 0 plus 1. So how I am adding 0 plus 1? 1 I am getting. Sum is the output, and there is no carry here. Okay, the carry is not getting here, and then sum is 1, carry is 0, and then 1 plus 0, that means sum is again 1 is that sum. Okay, there is no carry here. Okay, carry will be 0 again. Okay, there is no carry, there is no carry, all these three cases. But 1 plus 1, 1 plus 1 means in the decimal value 2, right? But in the 2 binary format, how we can write? So 2 is the binary value, 1 and 2, that means 1 is here and 0 here, that means 1 0 we are taking, right? That means 1 plus 1 we are adding, sum is 0 and carry is 1 here. Okay, my sum is 0 and carry is 1. Got my point
Yes,
here?
sir. Yes.
Ha. So that is the reason sum is 0, carry is 1. Then how you got this equation, right? So I told you already the k map. So two variable k map we need to write that. Okay, what is the variables here? I'm considering x and y, right? So in the left hand side you need to take the x, and then right hand side you need to consider y. Okay, so here 0 value will be considered here, 1 is here, and again 0 and 1. Then you need to write the combination of these two values, like 0 and 0. Okay, this box is consisting of combination of these two, 0 0, and this box is consisting of 0 and 1, and this box is related to 1 0, and this box is related to 1 1, right? You know how I am written this one. Okay, 0 means x bar, 1 means x. Okay, 0 means y bar, 1 means y. Okay, So 1 means that value is present, that's why y only I'm considered. 0 means that value is not present, that's why y bar only I'm considering here. Okay, now you can check that where I got the values in my truth table. Okay, so truth table, just I want to consider some output. Okay, this sum output where I got the values 1 in my truth table. See here, this is my value, decimal value 0, this is 1, and this is 2, and this is 3. These are the decimal values. Okay, these are the binary values. Okay, so binary 0 0. For 0 decimal, what is the output I am getting? Sum is 0, right? This is 0, right?
Huh.
This is 0 and this is 1, and I am getting 1 here. Okay, and at 1 I got the 1, and at 2 sum for sum I got the 1, and 3 I got the sum output is 0. Then these two variables are not able to form any pair. Okay, individual values only I'm considering. So this individual value, how can we write the boolean expression here or boolean variable here? This one is the combination of y and x bar, right? So that is the reason x bar and y I'm getting the value here. And this one is related to what is the combination of variables here? X and y bar, right? X and this row, this is the column and this is the row. Row is related to x and column is related to y bar. So x and y bar, then combined together you will get the sum output. Okay, sum equal to x bar y plus x y bar. Okay, so then how it is looking like? Exclusive OR gate, right? So the exclusive OR gate is the combination of x bar y plus x y bar. Then x or with y I will write simply. Okay, so that is my sum output. Okay, so that is the reason the XOR gate symbol is represented for sum output. Okay, got my point, Priya?
Sir, I understood that. Like almost like same like additional like addition how we are doing some carry the same kind of concept only, but
Ah,
through all this, like you are explaining like the X bar all that. I understood.
yeah, yeah. Same thing. Here also I'm taking some carry output I'm calculating. Now you will get a better understanding x and y. So same thing. A 0 here and 1 here. Again 0 and 1. So 0 means x is bar. Okay. And 1 means x only I'm considering as usual. And then 0 means again y bar and 1 means y. Okay, so then this is the combination of 0 0 and 0 1 1 0 1 1. Now you can see where you got 1 in your carry output. Okay, so at 3 position only I got the 1, right? For 3 only, that means both are 1 1 case only I got 1, right? So here I am taking the 1. Okay, this is the only case I got the 1, remaining all are zeros only, right? So at 0 0 I'm having carries 0, and 0 1 also carries 0, and 1 0 also I'm having the carry 0. Okay, so all these are
This concept like it is applied in everywhere, right? Right, sir. Like in
ha.
digital, whatever concept we use. Yeah.
Yeah, yeah, whatever the digital concept we are applying, that will be um, the concept we are applying anywhere. Okay.
Like mostly for designers, they while designing code, I think they use lot of digitals, right? Compared to verification.
Yeah.
Compared to
See,
verification.
this is the combinational circuit I am designing. This is the hardware we need to design by using the truth tables, Boolean expressions, and that is the reason we need to learn digital basics, right? Understood?
Yeah, yeah, understood. Like
Huh.
compared to like, designing, it's more important. Like compared
Yeah.
to verification, like they use
Huh.
more, right?
Yeah. Yeah. Yeah.
Since they have to scratch write the code
Hmm.
based on the
Hmm. Yes. Yes.
scra-
Then
from scratch. Yeah.
yeah. then full adder. So see, are you understood how I am writing these values? 000, 001, 010, 011. How I am writing? Are you understood?
This is 0, 1, 2, like that. 2, 3.
Like binary code,
Binary
842.
code, yeah.
So this is 1, and this is 2, and this is 4, right? And then decimal value is 0. This is my decimal value. So this decimal value, what is the binary value? All are not present, right? 4 is also absent, 2 is also absent, 1 is also absent. Okay, that's why I have considered all zeros, right? And 1, how I'm writing? At one position I want to write 1, and remaining 4 and 2 0, right?
Yes. Sir, 4 to 1, how it came means 2 to the power of 0, 2 to the power
two,
of 1, 2
2
to the
power
power of
0, 2 power 1, 2 power 2, right? And then
oh,
if you consider 4 inputs means 2 power 3 also will get. That means 8 also we will get, right?
yeah, yes.
Depends on the bits. We will consider, suppose 2 bits only considered means 2 power 0, 2 power 1. That means 1 and 2 only we are getting. And then 3 bits you are considering means 2 power 2 also will get. That means 4 also we will get. And 4 bits you will consider means 2 power 3. That means 8 also we will write. And 5 bits means 2 power 4 also we will get. That means 16. Okay, in this way we will increase that. Okay, we will increase the binary values. Number of bit depends on the bits, the values will be increased. Okay.
Yes. Like as usual, like 1, 1, like how we are writing
uh,
1, 2, 9,
so
like that
then
we are using. Yeah.
2 means 010, 3 means how we are writing? 2
Like,
plus 1.
yeah, in 2 position and 3 position, it is there, right?
Yeah, then 4 how we can write?
Only in
fourth,
fourth position.
fourth position 1. So
Mm.
then 3, 2 and 0, 2 and 1 will be 0.
Mm.
5 means what? Okay, 4 plus 1 5. 6 means 4 plus 2 6. 7 means 4 plus 2 plus 1, right? Now
Mm.
tell me the sum output and carry output here. Okay, so
Mm.
how we are getting? 0 plus 0 0, 0 plus 0 sum 0, carry also 0. And 0 plus 0 0, 0 plus 0 0 plus 1 sum 1, carry 0, right? See,
Yes, sir.
0 0 plus 0 0, again you need to add plus 0, then sum is also 0 and carry is also 0. Okay, same way here also 0 plus 1. Okay, 1 I am getting, and then plus 0 here, then sum is 1 and carry is also 0. Again, at
Normal
what?
addition, right? Like simple
Normal
addition.
addition condition only. At
Mm.
what condition we are getting the carry? See, 1 plus 0. Okay, so 1 plus 1. Okay, then I am getting the sum 0, carry is 1. Okay, this is my carry, this is my sum. And again 1 plus 1. Okay, sum 0, carry is 1. Okay, this is my carry. Again plus 0. Okay, sum 0, carry is 1. This is my carry, this is my sum. Okay, again what is the other thing? 1 plus 1 plus 1. Okay, 1 plus 1 sum is 0. Okay, carry is 1. Okay, again plus 1 you can add, sum is 1, carry is also 1. Okay, so in this way I will get the sum value and carry value. Okay, so then you need to again design the K map, or again you need to calculate the Boolean equations from the K map. Okay, so now here three variables we got, right? So then three variables, how many combinations we are getting? Eight, right? So
Mm.
then three variable K map we will write. So this is the three variable K map. Okay, so here the right side, what is the most significant bit here? X, right? X we can write here, and then yz we can write here. How I am writing two variables here? Two variables, four combinations I am getting, right? Y bar,
Mm.
z bar, y
Mm.
bar, z, and yz, yz bar. That means
Mm.
0 0 0 1 1 1 1 0. How I am writing? Y means 1, z bar means 0. Y z both are ones. Okay, y bar means 0, z means 1. Y bar means 0, z bar means 0. Understood how I am writing here?
Yes, sir.
X bar and x, 0 and 1. Now you can tell me here 0 0 0 is the combination, right? Because 0 and this double 0. Again 0 0 1. Again 0 double 1. 0 1 0. Okay. 1 0 0. 1 0 1. 1 1 1. Okay. 1 1 0. In this way we will write. That means this is the decimal value 0, 1, 3, 2, again 4, 5, 6, 7. In this way we will write. Understood?
Okay, sir. Yeah.
Huh. Then tell me what is the sum output where you are getting the value here. So in sum output, at 0 position I got 0 here, and 1 position I got 1 here, and then 1 2 position I got 1, and then 3 position I got that 0.
Mm,
Okay, so
mm,
and then fourth position I got 1,
mm.
and fifth position I got 0. Okay, so in
Sir,
this way
like while designing, like, is it mandatory to use K maps, sir? Like, if you're designing any hardware, is it
then
mandatory?
you don't want to use the k map, means you can write the direct boolean equations where you got ones here. Okay, see how I am writing the ones here. So at this position you got one, right?
Mm,
Which position? This sum is 1 at
mm,
0 0 1 case, right? So then I will write the sum equation directly. X bar y bar z plus, okay, here I got the 1, and that means 0 1 0. 0 1 0 means x bar y z bar. Okay, in this way I will write that. Okay, so this way you understand, means no need to calculate the k map. Okay, and you don't know how to write these ones and then equation, then go for the k map. Okay, that would be easy. In the k map, where we are getting the ones at that position only, I am writing the value. See, one position I got the one, and then two position I got the one, and fourth position I got one, and seventh position I got one. Then again you are writing the same values only. Okay, so then 0 0 0 1. Okay, that means x bar y bar z. Okay, and then again here I got 1. That means what is the condition here? X bar y z bar. Okay, that is the, and then here x y bar z bar plus, and other condition x y z. Okay, this is the output I am getting. Clear? By using K-map also I am getting the same output. By
yeah.
without using the K-map also I am getting the same output. Okay. Same way carry also you can calculate in the same way. Okay. So that is the basic thing we need to calculate here. Okay. Understood? See, this is the
Yes.
K-map I
Yeah.
have drawn here. Okay. Just wait a minute. This is the K map, how we are writing. Okay, so and then I got the equation like this. Okay, same equation I have written, and then here also we will get that. So x bar y bar z, x bar y z bar, and x y bar z bar, x y z. That is the exclusive OR gates of three inputs. Okay, again K map for carry. Carry, here we are forming the pairs here. Okay, how we are forming the pairs means, see, this is the one pair we can form. So both are nearer, right? Side by side we are sitting together, then pair we can form that. And then these are also pair we can form, these two are also pair we can form. Then you can say this is common variable 1 1 1 1 means yz, right? So for this equation we can write yz, and this pair, okay, this is another pair, this pair is common to 1, and this is also common variable is 1 is there. 1 means y, here 1 means x, okay, xy is the another combination, that is the another equation. And then another equation 1 1, again 1 is common, and then this one is common, this one means z, okay, xz. In this way we will get the carry equation, see xy plus xz plus yz. Clear?
Yes, sir. But actually, here you said x, y, z as a way, like we have, as a variable we had used, right? But
Boolean variables, yeah.
Boolean variable, right?
Hmm,
So
hmm.
we can usually we use x, y only two variables or three variables, sir. Usually, like in real time.
Full adder, this full adder is having three inputs, okay, that is default. Okay, so if you considered full adder means three inputs we need to consider. If you
Oh,
considered half adder means we need to get two inputs, okay,
like
so two inputs only.
if
Two
you're
inputs
designing
only.
full adder, then we need based on the like what we are
uh,
designing, we need to
Based
check.
on the circuit diagram we need to consider the number of inputs and number of outputs, okay.
Go.
So if you design full adder means we need to consider three inputs and two outputs, that is common sum and carry, okay.
Yes, got it.
Clear?
Yes, yes.
Fine. This is the full ladder circuit diagram, how we can calculate. So these are the applications where we are using the full ladders. ALUs purpose we are using the full ladders, and then some adders calculators purpose also we are using the full ladders. And then full ladders are also helping to carrying out multiplication of binary numbers. So then multiplication of binary numbers and then adding together, at that time also we will take the full ladders, right? Suppose A, B, C you are taking two inputs binary or two inputs multiplication A, B and C, D you are multiplying. Then B, D we are getting one output. Sorry, B, D, and other one is A, D, and one is C, B, and other one is A, C, right? So while adding these two, then we need some full ladder. Okay, here we can use the full ladder circuits. Okay. These are the applications we can use where the full adder. See, I told you now. So full adder and half adder. Half adder, two inputs we will consider. Okay, and then two outputs. Only two inputs we will consider, and the full adder, three inputs we will consider. Okay, so then two outputs we are getting sum and carry. Okay, here also we are getting two outputs sum and carry. Okay, so here also we are getting one exclusive OR gate and one NAND gate, but in the full ladder two exclusive OR gates over two AND gates, one OR gate is required. Okay, so that is the basic differences between the full ladder and half adder. Okay, full ladder and half adder both are combinational circuits, both are used for adding purpose only, but half adders are just for sum and carry we are getting, and full ladders we are utilizing ALUs, all these things. Okay, whenever you are adding some different values, at that time we use full ladders. Okay, and half subtractor, half means again two values, okay, two inputs I need to consider. But here the problem where we are getting means 0 minus 0 no problem, right? So difference is also 0, and there is no borrow here, so borrow is also 0, right? And 1 minus 0 is also no problem, difference is 1, and borrow is also 0. And 1 minus 1 also there is no problem, difference is difference 0, borrow is also 0, right? But what is the problem
But
here?
borrow means
0
it is
minus
not
1
carry,
is
right? It is not
huh,
carry.
not carry. Here borrow, like lending something,
Lending,
right?
right? Yeah.
Lending something from others. Okay, borrowing something. I don't have pen, so then I'm asking you. Someone is asking the pen. Still, I don't have pen. Then I am asking also some other person. Okay, so that is the borrowing here, right? See, Here he's don't have any money, but someone is asking 1 rupee, then he want to borrow 1 rupee. Okay, so then added here. So added beside the zero. 1 0 means what? 2, right? Okay, the binary value 1 0, then decimal value is 2. 2 minus 1, then difference is 1. Okay, so that means you will get the difference 1, again borrow also 1. How I am getting 1 and 1? Are you understood? See, 0 minus 1, we can't subtract, right? I need to get some borrow. So, borrow is 1 I need to get. This borrow we can add beside this 0. Okay, 1 0. Okay, then this 0 will become 10. This 10 means decimal value 2, right? See how I'm saying 2, 1 and 2, 1 0. So then at the 2 position I got the 1, and then 1 position I got the 0. That means the decimal value of this one is 2, right? Understood?
Yeah.
2 minus 1, what is the value? 1, right?
Mm.
Then borrow is 1 and difference is also 1. Clear?
Not able
This
to
is
subtract. Okay, we are borrowing that time, right? One.
not able to subtract. Then we are borrowing 1. That 1 is added here. Then 1 0. 1 0 means this value is 2. 2 minus 1, we are getting the difference is 1. Okay, difference is 1 and
But we
borrow is
always we need to borrow zero only, like one only, right, sir? Or
1
is there
only.
any condition we can borrow zero as well?
No, no. How we can borrow the zero? So because I'm having enough money. How I can borrow? So there is no right. There is
Got it.
then zero
Uh,
we can borrow means that is no use, right? So just I need some emergency. Then I will ask you. Then you will give some money. Then that is I'm lending you. I'm borrowing some money. Okay. So that is my liability, right? Yeah.
yeah, got it.
Fine. Okay, then you understood this diagram. Both are same. How I am writing this? Then tell me the shortcut way I told you, right? I have explained you. So how I am writing the equation A XOR B here? For the borrow difference, for the difference a XOR b output I am writing. So that means a b bar plus a bar b output I am writing. How I am writing? Just tell me the equation from the truth table here. So where you got ones here? This position and this position, right? That means
Second one and third.
Ah, 0, 1, and then that means 0, 1, 2, 3. At first one, second, we got the ones, right? So then, how we can write the equation here? A bar B plus AB bar, right? That is the exclusive OR gate symbol. Okay, sorry, equation. A bar B plus A bar B, AB bar. That is the exclusive OR gate operation. That is the reason I am writing the AX or B. Are you understood, right? How I'm
Yes.
writing the equation?
Yes.
And then borrow equation, where you are getting the borrow equation? One, only at one position. One
And
position
once
means
only
ah,
if in the second row we are just borrowing.
ah. Then what is the equation here? A bar B, right?
Mm.
Hmm. A bar B. That is the reason I'm connecting one NOT gate. Then I'm getting A bar. So A bar is the input here and B. Then A bar B is the output I'm getting. That is the half subtractor. Same way, full subtractor also you can learn. Okay. See, this is my full subtractor. So then, where you are getting the difference here? See, 0 minus 0, all these things are 0, but difference 0, borrow is also 0. And which is the position now? This position we are getting the problem. 0 minus 0 means no problem, difference is 0 and borrow also 0. 0 minus 1 means difference also 1, difference also 1, borrow also 1, right?
Yes.
1 again here also. 0 minus 1, difference also 1, bar also 1. And again, This condition you need to take care of that. 0 minus 1 means difference 1 borrow 1. This is my difference and this is my borrow. But again 1 minus 1, that means what? Difference is 1, 1 minus 1, difference 0, borrow is 1. In this way difference is 0 I got and borrow is 1. Clear how I am getting? See, initially what is the value? 0 minus 1. Okay, 0 minus 1 means I am getting the difference. This is my difference and this is my borrow. I need to get 1 here, and then difference also 1. Again another value is there, that is 1. 1 minus 1 means difference 0. This borrow will be as it is, we will get the output side. Okay, that is the reason 1 0 we are getting. Clear?
Yes, yes.
This will you can take care of that. Then there is no problem here. 1 minus 0 means difference is 1, borrow is 0. Okay, difference is 1, borrow is 0. And 1 minus 0 is also no problem. 1 minus 1 also no problem. 0 is borrow 0, difference 0. And 1 minus 1 also no problem. But again here also another problem. 1 minus 1 means difference 0, borrow is also 0. But 0 minus 1 means again difference 1, borrow 1. Okay,
Yes.
because 0 minus 1 means again I need to get the borrow value 1 and then added here. This is 2, 2 minus 1 again, difference is 1 and borrow is also 1. Okay, in this
Got it.
way I'm getting the 1 and 1. Okay.
Yes.
Just ask. So this is the full subtractor and then decoder. Okay, 1 to 2 line decoder. See, decoder means we are giving n number of inputs and 2 power n number of outputs I am getting. Okay, that is the decoder. That means one input you are giving, 2 power 1 outputs we are getting. That means 1 by 2 decoder. And then two inputs we are giving, 2 power 2 outputs we are getting. That means 2 by 4 decoder. Okay, three inputs we are giving and then 8 outputs, that means 2 power 3. That means n inputs I am giving, 2 power n outputs I am getting. That is the decoder block. Okay, so decoder is used in the receiver side. What is the main purpose of decoder means decoder will convert machine understandable language into human understandable language. Okay, human understandable machine understandable language into human understandable language. Okay.
Encoder means it converts to machine language, right?
Machine encoder is converting that human understandable language to machine understandable language.
Got it.
Okay, that is the difference here. So
So
here,
every hardware it is important to use encoders. It's
ha,
mandatory.
yeah. So everywhere we are utilizing all these things. So in the receiver side, we are utilizing the decoders, and the transmitter side, we are using the encoders. Okay,
Yes. Got
in
it.
this way, we will design our logic gates. Okay,
Got it.
combinational circuits.
Got it.
Okay. Then this is the 2 by 1 decoder. That means only one input I am giving. A is the input and 0 and 1, two combinations. What are the combinations of outputs I am getting is D naught and D1. 0 condition, D naught means 0. D1 means 1. Okay. Don't get confused. D naught means that value is 0. D1 means 1. D2 means 2. D3 means 3. D4 means 4. Okay, basic numbers only. That means 0th position, the binary value is also 0. That's the reason D naught is present. And 1 we are giving, binary value we are giving 1, and that is the reason D naught, D1 will be the output I'm getting. Therefore, D naught is equals to A bar, D1 is equals to A. Okay, then here I am getting the min terms like M naught comma M1. Okay, these are the min terms I'm getting. So now you can take the A value as an input and connect one NOT gate here. Okay, so A value as an input. Okay, connect one NOT gate here. then this not gate is connected to A is connected to D. Okay, sorry, D not. A is connected to D not, then D not is equals to what is the output I am getting? A. Sorry, so D not, D1 is connected to A. Okay, this is the connection. And this is the A bar, this line is connected means that is D not, I am getting the output is A bar. Okay, so this is the connection. This wire is connected to D naught, then A bar I got that. This wire is connected to A, and then D1 I got that. Okay, how we will write this value? Okay, A is my input, A D naught, D1 is the D naught, D1 is the outputs. Okay, same way 2 by 4 binary decoder. Okay, two inputs I am giving, four outputs, I will get the output side q0, q1, q2, q3, four outputs. Same way I will design the truth table. First we need to draw the truth table, then only we will get the output equation. See, 0 1 2 3, these are the decimal values. This is the binary 1 2 1. Okay, 0 0 0 1 1 0 1 1 cases. Okay, for the q naught position, 0 0 means D naught, right? 0, right? That is the D naught. Sorry, q naught. Q naught means q naught is 1, q1, q2, q3 are zeros. Okay, again, so 0 1 means what is the output we are getting? 0 1 means 1. At 1 q1 position I am getting the 1, and then remaining positions all are zeros. See, in the encoder and decoder, every time one input we need to select, and then one output we are getting. Okay, so in this way we are selecting the inputs, and we are getting the one output here every time. The remaining outputs will be 0. Then 2 means q2 will be 1, and q0, q1, q3 will be 0. And 3 means what is that? Q3 will be 1. Okay, so q2, q1, q0 will be 0. Clear? So
Yes, sir.
for Q naught, what is the output equation? A bar B bar, right? So that
Yes.
is the A bar B bar equation I'm writing. Here dash is also no problem. Dash is also represents that bar only. Okay. So Q1 is what is the output equation? A bar B, and Q2 means AB bar, and Q3 means AB. I'm getting the output. Okay, how we can draw the circuit diagram here means this is A, and I'm drawing the one NOT gate. Beside that I'm getting the A bar here, and B I will write here, and I'm taking another NOT gate, then here B bar. So one AND gate I'm taking that. So one line I'm passing, this line is connecting this Q naught value. Okay, Q naught is the output, it related to A bar and B bar. So just connect the A bar and B bar. In this way also we will draw, or otherwise this way also we can draw A bar and B bar. So two switches individually we can take that. Okay, and again another q1, what is the output we are getting? Q naught is A bar B bar, and q1 means this is another AND gate, again pass the another line. So q1 means A bar B, right? A bar B means A bar it is connected, and B is connected here. This line will tells you the B value, and this line will tells you A, and this line A bar, and this line is B bar. Okay, understood how I am writing? And another AND gate we can take that. So what is the
Like the truth table, you're just following and creating the gates, right?
that's it, yeah. So based on the truth table, I'm getting the output equation, and then drawing the logic diagram. Okay. So this is the logic diagram. Q2 means AB bar, right? So AB bar is the output equation here, Q2 AB bar. So A is the connection, and B bar is the another connection. Okay. This is the representation. Same similarly, 3 by 8 decoder. 3 inputs I am giving, and 8 outputs I am getting. Okay. So A bar is 0, 0, 0. That means Y naught is the output. Okay. 0, 0, 1. y1 is the output, and 0 1 0 y2, because this value is 0 1 2 3 4 5 6 7. Okay, based on that, 0 will be present, 1 will be present, 2 will be present, 3 will be present, 4 5 6 7. Okay, so if 5 is there means y5 is the output I'm getting, 6 is there means y6, 7 means y7. Then based on that you will get the output
Got it.
equations. Got it? And then draw the logic diagram same way. Okay, this is the multiplexer. We are giving multiple inputs but single output we are giving. See, multiplexer having uh, inputs as well as select lines. Okay, here 2 power n by 1, this n defines that select lines. Okay, select lines. And then this 2 power n defines that input lines. 2 power n is defines that input lines. Okay, that means suppose 8 by 1 mux you are designing, this 8 I am writing like this, 2 power 3 by 1. Okay, this 2 power 3 means what is that, 8, right? 8 inputs I am having. Okay, how many select lines are there? This 3. Okay, 3 select lines I am having. Okay, in this way we will design the multiplexer. Suppose 16 by 1 multiplexer I am designing that. Okay, 16 by 1 means 2 power 4 by 1, right? So this 4 indicates that select lines. Okay, 4 select lines we are having for 16 by 1 multiplexer. Okay, how many inputs we are having? 2 power 4. 2 power 4 means 16 inputs, right? 16 inputs we are having. Okay, so that is the representation. Now tell me, 32 by 1 multiplexer you are designing, how many inputs are there, how many select lines are there? 32 by 1 mux you are designing.
Select lines, I think 4, right, sir?
No, 5, right? 2 power 5. 2 power 5 is
Yeah,
32.
32. Yeah, okay, okay, got it.
Ah.
32.
So then 5 select lines are there.
Hmm.
Okay, 5 select lines are there. So 32 inputs are there from 0 to 31. Okay, that is the multiplexer. See, multiplexer is having selecting one out of the m inputs. Okay, a set of two select lines, set of two select inputs is required where m equal to 2 power n. Okay, so set of two select lines means, see, suppose we are designing 4 by 1 multiplexer, then two select lines are required, and then every time one input we are selecting, right? Every time one channel we are seeing in our television. Okay, so that is the multiplexer representation. Okay, same way 2 by 1 mux I am designing that. So this is my 2 by 1 mux. How many inputs I am having? Two inputs I am having. One select line, that is yes. If yes is 0, okay, select line is 0, output I am getting I naught. Select is 1, output I am getting I1. Okay, so how we can write the equation means y equal to s bar into I naught, s into I1. Okay, 0 means s bar, s1 means yes, then s into s bar into I naught plus s into I1. This is my output equation. Based on this I want to draw the logic diagram. Okay, same thing, we can consider the s line and then another s bar line. Okay, draw the one and gate. So fix it that I naught, and then s bar is connected here. Okay, s bar into I naught into s bar is coming here, and take another and gate. Okay, so fix that I1. Okay, I1 is fixed, and then s is connected here, then s into I1. In this way I will get the output. and these two are connected to one OR gate. Okay, so these two are connected to one OR gate. I will get that I naught into S bar plus I1 into S. Okay, in this way I want to write the logical expression for 2 by 1 multiplexer. Clear? See how many combinations we are having means, see select 2 by 1 mux means select is 0, I naught is 0, I1 is also 0, then output I am getting 0 only. And then select is 0, I naught is 0, I1 is 1, again I am getting 0 output only. And then select is 0, I1 is 1, I naught is 1, I1 is 0, then I'm getting the, see I naught value only I'm getting at the output side during select equal to 0. Okay, during select equal to 0, I naught values only I'm getting. During select equal to 1, I1 values only I'm getting the output side. Okay, so whatever the I1, I naught value, I1 value 0, then output is 0. Whatever the I1 value 1, and then output is also 1. Clear? Hello?
Yes, sir, I got it.
Ha, fine. So same way 4 by 1 mux also I am designing that. 4 inputs, 2 select lines. So those 2 select lines are 0, that means S naught and S1. That means 0 0 0 1 1 0 1 1 combinations we are getting, and then output I am getting I naught, I1, I2, I3. Depends upon 0 1 2 3. Okay. So that is the reason I'm getting the outputs. Then based on that we will write the logic diagram. Okay, see if you are selecting 0 0 means I naught is getting the output side. You are selecting 0 1 means I1 is the output. You are selecting 1 0 means I2 is the output, and 1 1 means I3 is the output. Okay, that is the 4 by 1 mux. Similarly 8 by 1 mux also, 3 select lines are there. Demultiplexer means reverse of multiplexer. Like so you are the only listener from my side, same way I am the only presenter. Similarly some of the persons are also listening, that is the demultiplexer. Like radio, so how FM is producing, right? Only single channel is there, but multiple users are there. Okay, that is the demultiplexer. Okay, so demultiplexers in the radio transmitter side we are using that. Okay, so single channel is there and multiple outputs we are getting, like broadcasting, like TV9 channel is the single channel, but multiple users are at a time watching that. That is also demultiplexer. Okay, so many single transmitter, many users are there. And select lines are same. Select lines means based on the select line only we are getting, see 1 by 4 demultiplexer means one input, so two select lines, four outputs. This is the four outputs. That means 2 power n by 1. So the, sorry, 1 by 2 power n. So this 2 power n represents that outputs. Okay, this n represents that select lines. Okay, this n represents that select lines. This one represents that input. Okay, that is the demultiplexer. Okay, so 1 by 2 demultiplexer I'm designing that. So 0 input I'm giving, select line is 1 select line I'm giving that. Okay, this select line 0 means I1 output I'm getting y naught. This is output I'm getting, that means a equal to 0. Okay, so then, so sorry, this a is getting at the output side, y naught side. And then select equal to 1, this a is getting at the y1 side. Same a is getting at different channels, either y1 side or y naught side. Okay, so that is the basic representation of demultiplexer. Okay, same way 1 by 4 demultiplexer, 1 by 8 demultiplexer. You will get to know, right, how I'm getting the 1 by 8 demultiplexer. Do you need to explanation, or you will study?
Not necessary, sir. I'll just go
Ah,
through this one. Then
yeah,
only
yeah.
yeah.
Fine, fine.
Can send me the slides.
Okay,
You-
I will send that. So I will share this PPT with you. Okay.
Previous class slide also, sir.
Okay, okay. So how much time it is recorded? 20 minutes. Huh? అదేంది 20 minutes రికార్డ్ అయింది వీడియో?
అవునా సార్? అప్పుడే స్టార్ట్ చేశారు కదా, నేను అప్పుడే విన్నాను.
అంటే మనం 8కి కదా క్లాస్ స్టార్ట్ చేసుకున్నాం. అంటే 1.5 hour మినిమం రికార్డ్ అవ్వాలి కదా. ఓకే, ఫైన్, నో ప్రాబ్లం.
మీరు మళ్ళీ ఆ యూట్యూబ్ వీడియోని మళ్ళీ మాడిఫై చేసి పంపిస్తారా సార్? లైక్ నేను దాన్నే చూసి చూస్తాను. లేకపోతే
దాన్ని దాన్ని మోడిఫై చేసే పెడతాను నేను.
ఓకే సార్. పెట్టిన తర్వాత నేను చూస్తాను మళ్ళీ.
ఓకేనా?